This video is going to go over box plots. We're going to look at the parts of it and how to read it. The parts of a box plot, there's only 5 key parts. The first end of the line is the minimum value, the lowest number. The last part at the end of the line is the maximum or highest value. The line that's inside the rectangle, not necessarily in the middle, but the inside of the rectangle, is the median number. And then we have the lower quartile and the upper quartile. Those are the only 5 parts we know. So again, a box plot is a really great way to display a whole lot of data. If you have a large group, instead of making individual points, we can use a box plot to summarize. I already said there's 5 key values that you can see when looking at a box plot. And you never know the total amount of the numbers in a list. I can never know the total. A couple other things that I want to point out is you can find the range in this set. If I take this dot or value and this value and I subtract these two, subtract the lowest from the highest, if I subtract them, that equals the range. And I'm gonna label those. Again, this would be your lowest number. It says max, but if that doesn't make sense to you, then you can put that this is the highest number. The other thing that I want to point out is that the median is known as the middle number. So whatever goes right here, that is the middle number. There's 2 other things that I want to have you put down on your notes if you're in my class that are important to know. You cannot find the mean when given a box plot. You can't find the mean. There's no way to know the average. Also, you can't find the mode because we don't know the individual numbers that were in the grouping. So please make sure you add that to your notes if you're in my class. Now, the box itself, or the rectangle that's right here in the center, we use this piece of information to find something called the interquartile range. It's kind of like range, but we're only looking for this inner portion of the graph. Another vocab word that you might need to know for this is spread. The spread is looking at the rectangle like you spread if the rectangle was a piece of bread and I were to spread peanut butter from one side to the other. Okay, that is what is also known as range. And in order to get that calculation, what we would do is we would subtract. Let me back up and get a pen. Q1 and Q3. So this value and this value, I'm going to take those together. Boom. Q1, Q3. What I do is I take those 2 values and I subtract them. So this is the IQR. I need to subtract to get the range. I would say Q3 minus Q1, and that tells me what the interquartile range is. IQR. This is a value that's asked a lot. The interquartile range is a value that's asked a lot when you're doing box plots. So a couple things that you need to know. Sometimes the rectangles are not the same size. Some parts of the rectangle are longer than others. That means there's more variation when you have a longer rectangle on one side of the graph compared to another. Now, I think if you're in my class, this might be left blank, so you need to fill in this. If you have a longer rectangle on one side than the other, that means there's more variation in the data for that part of the graph. Then the opposite is true. Sometimes the rectangles are exactly the same size. That means there's less variation in the data. They're all very similar. So I'm going to underline that. That means the numbers are very similar to each other. But when there's more variation, then that means the numbers are very different from each other. There is one other thing you need to watch for on box plots. Sometimes the rectangles are scooted really far to the right or the left. They're not always in the center. So watch out for when that happens, and that would indicate that the data is skewed. I think if you're in my class, that you need to fill in that blank as well. And that means almost all of the numbers are really high or low is when the boxes are scooted really far to one side or the other. Okay, the three examples you see on your screen right now, they show different important parts of box plots that we need to identify real quick. If I zoom in on this first one and you take a look at the size of the rectangles, these are both the same size. If I were to highlight them or shade them in, they take up about the same amount of space. Well, since they take up the same amount of space, that tells me that there's very little variation in the data. All the numbers are real close together. So when you have same size rectangles, means less variation. Same size rectangles mean less variation. Okay, now when I look at the second one, I zoom in on it and I highlight those two rectangles with different colors. I can easily determine that these are not the same size. When I have different size rectangles, especially with this much, that means there's going to be more variation. So example 2, I'm going to say different, whoops, I'm still on highlighter. Erase real quick. Different size rectangles. Different size rectangles mean more variation. The numbers are spread out far from each other. The third example, we're not going to look at the rectangles on this one. The thing we're going to point out and look at are these lines sticking out on the edges of the box. If I look at those individually, this left side has a very short line, but the right side has a very long line. Now, we said that at the beginning, these dots on the ends mean the lowest and highest number. And if the line is very long, that means there's going to be an outlier. So if I have a long whisker, a long line pointing out to the left or right, that means there is an outlier. Means there is an outlier. That's why it's really far out away from the rest of the group. Now what I'm going to do with this last example is I'm going to take an actual number line in the box plot that's above it. I'm going to identify these 5 key parts, and then I'm going to answer some questions. So the number line, the label for it says 7th grade math test scores. So my lowest score, when I match these up, the lowest score would be 60. The highest score would be 100. The median score is going to be just past 80. I would probably say this is 81. If you were estimating and said 82, could be possibly okay. The first part of the rectangle where Q1 is, that looks like it's right in between 70 and 75. I'm just going to go with 72. Could be 73. Your choice, though. And then the end of the rectangle matches up perfectly with 90. So these are the key parts of the graph that I could find. Now I'm going to answer the questions that have been placed with this particular graph. The first question says, what is the median test grade? So I've labeled these. I'm going to identify what this is asking for. Median means middle. I want to know the dot inside the rectangle. Okay, so I'm going to put that down as inside the rectangle. For my notes, this is going to go back and help me be able to answer these questions later. So the median would be 81. The second question for analyzing this data, it says, what does the median tell you about all the test grades? Well, median means middle, so that means half of all the grades were below and half of all the other grades were above. Really is what median tells you. It tells you the halfway point. What does median tell you? It means that's exactly the halfway point. It is the halfway point. Could be one way to say it. It is the halfway point. Or I could either say half the scores are below or I could switch it, and then instead of saying below, I could say half the scores are above. That could be a comparison statement that I make. So same graph, I'm going to label these just like I had it a second ago. This was 60, this was 72, this was 81, 90, and 100. I just didn't have room on my other screen. This question says, what's the lowest test grade? That would be the first dot, which we've identified as 60. Whoops. Then the next question says, which one is the highest? Highest test grade, which would be the last dot, 100. Then this one says range. Regular range. To do regular range, you need to take the first dot and subtract it from the last dot. The lowest and the highest grade, you subtract them. So in order for me to say that answer, I would just put 100 minus 60, which is 40. The range in scores is 40 points. And then the final question that I'm going to answer is spread, which also means IQR. IQR is when I do Q1 and 3 and I subtract them, which would be the parts of the rectangle. So right here would be Q1, right here would be Q3. If I subtract those, the numbers I selected, 90, and then I said that was 72. So when I subtract those, I'm going to get 18. So just to review, a box plot only tells you 5 pieces of information. It tells you the lowest number in the data set, the highest number in the data set, what the middle number would be. It doesn't have to be always in the middle of the rectangle, but it is a line in the rectangle. And then you know your Q1 value and your Q3 value. And remember, those are the numbers that you use to subtract to find IQR.